We are now moving on to rational exponents, and I would like to start off first by looking in the textbook. Here we have the definition of rational exponents as well as a study tip that's actually a very important example of the rules that we have up here. So go ahead and pause the video and read through this, and then read through the study tip as well, because it's actually a very important example that shows why things have to be a real number, things have to work in a certain domain, and that you have to consider these before you carry out all of your executions. So this point right here, very, very critical. So beware of that in case we use any examples like that on future quizzes or tests. All right, so again, pause it if you need to, but I'm going to go ahead and move on now. So we're going to go ahead and work with rational exponents and change from a radical to an exponent, or from an exponent to a radical. In example D, continuing from the last video, we're going to work to change a radical into exponent form. So in this example, we're given the fifth root of g cubed. And actually, this is a very easy process. The index, which is the number outside of the radical, indicating what root you're taking, is actually always going to be the denominator. So here, we're going to get g. It's still to the third, but it's to the third over 5. So the 3 attached to the variable stays up there as the power, but the index becomes the denominator in our rational exponent. And that's actually it for example D. Now let's go ahead and work in reversed and go from exponent to radical form. We're going to use a harder example this time to see if we can really apply our knowledge. And here in E we have xy, the whole quantity, raised to the power of negative 2/3. Alright, now first off, we already remember that we can't deal with negative exponents, so we got to get rid of that first and rewrite this with a positive exponent. So xy to the 2/3 power. Now here we know xy is raised to the second power with a division by 3, which means we're actually taking the cube root. So let's go ahead and get rid of that denominator right now and rewrite this as 1 over cube root of the quantity xy squared. So we can't simplify anything at this point because it is a cube root and there's only a squared value inside. However, we could rewrite this as 1 over the cube root of x squared y squared. Let me make that a little more obvious. And there we go. That is actually as much as you can do. We went from exponent to radical form. And now our final example, we're going to go from a rational exponent and we're actually going to simplify a bunch of problems, well, one single problem, in which we have a variable and a constant raised to certain powers. So we're going to simplify. Let me push this up. This is as much room as you'll need. We're going to have 2x squared raised to the 3/2 power all over 2 to the half and x to the third, or times x to the third. Here we can't really do anything just yet because we have these parentheses and exponents. So remember your order of operations. We're going to raise everything to the power first. So here we have 2 to the 3/2 power, then x 2 to the 3/2 power, which is basically 2 times 3/2. The 2 and the 2 cancel, and we get x to the third. On the bottom, we're still left with 2 to the half and x to the third. Nice thing here is that the x to the thirds cancel each other out, and we're left with 2 to the 3/2 over to the 1/2. At this point, I'm going to bring this guy up to the top. They have the same base, so I can work with them together. So now it's a negative exponent, and I'm going to add these two exponents together. 3/2 plus negative 1/2 is 2 over 2. Same thing as 2 to the first, and more simply, just 2. Alright, so we simplified something with rational exponents, with a variable as well as constant. At this point, you should be able to answer the questions on the Google form.